Alright, so while we've got this dehumidifier here, I thought I'd do just a quick video on like basics of refrigeration. Most systems, now this is a very simple system, your standard dehumidifier. So basically you have your low side, high side port, which is suction and pressure on your compressor. Every refrigeration system has a compressor, with the exception of ammonia systems, which basically just heat the ammonia and then it cools through a condenser. But you have basically three main parts to your refrigeration system. You have your compressor, you have a condenser, and you have your evaporator. Now, the compressor pulls in the gas at a relatively low pressure. Now, relatively, we're speaking as in this system runs on high side is 360 psi, low side is 144 psi. And again, most systems, you're going to have your condenser is, say, for an air conditioning, home air conditioning system, or even a window air conditioning system. Your condenser will be outside with a fan blowing through it, and your evaporator will either be in your furnace, in your air handler, or again on the inside part of the window air conditioner with another fan blowing through it. In the case of a window air conditioner, the two fans are connected on the same motor. In the case of a dehumidifier, you're not going really for the cooling action, or heating action, but most of the time they do end up blowing heat, because it generates more heat than it does cool. But you only have one fan which blows air over both the units. It'll blow forward, pulling the room air, the damp room air, over the evaporator, and then blowing it, the slightly cooled down air, over the condenser, and then blowing it out the front of the unit. But anyway, so you have your compressor. You've got two lines coming in and out of that. This is your high side line, which would be your liquid line, which it's not liquid, it's just high pressurized gas at this point. It runs out of the compressor through a receiver dryer unit, which acts as somewhat sort of a muffler. And I'm not sure if these actually have desiccant in them or not. I've never split one open, but when we tear the compressor apart, we might do just that, see what's inside this thing. But it's usually a filter, and then it has a desiccant in it to remove any moisture in the system. So that goes up through here as a heated compressed gas, and goes into your condenser, which as it cools down, it condenses into a high pressure liquid, and then it comes out the condenser through this tiny tube, goes up through here, and then into now again, this is a very simple system, and most refrigerators are set up the same way, as are most window air conditioners. Now when you get into larger systems, such as commercial refrigeration, or home air conditioning, or even an automotive system, will have a I was just thinking of it like a minute ago, and it's gone. Expansion valve. Anyway, what the expansion valve does is it allows the liquid comes through this line, it enters the larger space of the expansion valve, and the expansion valves are usually thermostatically controlled, whereas these are just a fixed orifice in here, which is basically little tube going into bigger tube. Like I said, very simple system, but when the liquid goes into here, this is a much lower pressure than this, and the gas expands, or the liquid expands, vaporizes, and cools as it's going through these coils, and it then is a warm gas again by the time it gets to this side of the coil, where it starts the cycle all over again, when it gets pulled back into the compressor and compressed again, and we start back again on our high side. So anyway, that's just a basic, very simple, fast explanation of how refrigeration works. There's a lot more to calculating size of units versus airflow and room size, and even if you're constructing a system, compressor size and coil size and type and amount of refrigerant that you need. But anyway, that's just a simple video, and I just knocked something over, so thank you for watching.